All right, so we are starting graphing, and we're going to talk about transformations. So we talked about all the parent functions last time, so we're going to talk about the actual transformations that happen with our graphs. And the translations, which we're starting with, those you did, and those came, at least the vertical ones were in Algebra 1. I think you didn't do the horizontal ones till you got to Algebra 2. But this all kind of started way back when. So we have translations. If this solid line is f of x, if I shift it up or down, then the down is going to be f of x minus d. And then if I shift it up, it's f of x plus d. Okay, that f of x being whatever function it is. If it's a squared, x squared plus 5 or something like that. But it's after you do whatever the operation is. If it's squared for a quadratic, square root for a square root, whatever. It's like outside of all of that. If we're going to shift it left and right, there's one thing we got to remember. X lies. Okay? So this is on the inside with x, and x lies. So down being negative and up being positive totally makes sense. If I'm going to go to the left, then that is f of x plus c. Right is f of x minus c. Because it looks backwards, right? X lies. So if it looks like you're supposed to go to the right, you actually go to the left. So if I'm here and I have a plus c, I go to the left c units. If I'm here and I have a minus c, I go to the right c units. X lies. Okay? We all good with that so far? All right, so then we have reflections. If I reflect in the x-axis, so here's what I want you to think about. If I have some point here, x, y, whatever that point is, and I reflect it in the x-axis, it ends up right here. What didn't change, x or y? X. X stays the same, the sign changes on y, right? So if I'm going to reflect in the x-axis, the sign changes on y. Y is f of x, so this would be negative f of x. It's like negative y. Okay? If I have a point here, again, x, y, and I'm going to reflect it in the y-axis, it ends up here. This time, y stayed the same, and I changed the sign on x. So a reflection in the y-axis changes the sign on x, so this would have to be f of negative x. Okay, does that make sense, how that works? Okay. Right, so then our dilations, our compressions, and our stretches. Right, so if I'm going to have a vertical dilation, okay, that means this is going to affect y. Anything vertically done affects y. Okay, that's my vertical dilations. It's affecting the y value, which means it happens after we have done whatever the operation is, squared it, square rooted, whatever. We have done something with x, and now we do something else that affects the y value. So this is my original one. So my compression would be a times f of x, and actually the stretch is also a times f of x. If I'm multiplying something, it's a stretch or a compression. What changes it from a stretch or a compression is the value of a. So if a is, the absolute value of a anyway, is greater than 0. Oh, wait, that's compression. I'm sorry. Ignore that. I was doing stretch, and that's clearly says compression. I don't know where my brain is. If the absolute value of a is between 0 and 1, means if it's 1/2, 1/3, 2/3, okay, it's a positive number, but it is fractional. But be careful with just the fractional thing, because if I had 3/2, that's a fraction, but that's actually bigger than 1, right? So it has to be less than 1. If it's a stretch, then the absolute value of a is greater than 1. So if it's 2, 3, 4, which makes sense. If I multiply something by 4, it's going to get bigger. If I multiply something by 1/2, it gets smaller, right? That's how it works for vertical. Your horizontal dilations, that's when it affects x. So it's on the inside. So this is f of b times x for a compression and for a stretch. Well, if I multiply something by x and it's a compression, and that means it's going to get, my x values are going to get smaller, then the absolute value of a is actually greater than 1 because x lies. So if I had f of 3 times x, it looks like it should get bigger, but it gets smaller, and we have to use the reciprocal. And we'll look at that in just a second. For the stretch, that's when the absolute value of a is between 0 and 1. So if it's fractional. So the x and y's work differently. Y makes sense logically. X lies, so you have to do it backwards. So when we compress or stretch vertically, so it will compress or stretch vertically by a factor of the absolute value of a, whatever it is. If it's 2, it stretches by a factor of 2. If it's 1/2, it compresses by a factor of 1/2. For horizontal, it will compress or stretch horizontally by a factor of 1 over the absolute value of b. So if it's 3x, then it'll compress by 1/3. If it's 1/2 x, then it'll stretch by 2. We use the reciprocal, and it's the opposite. Okay? But they're all absolute values because the negative does the reflection. It's a totally different thing. Okay? We all good so far? Yes? All right. So on the back, double check. I think I fixed it on your copy, and I didn't fix it on my copy. After C up here, you should have 2 parentheses. I think you do. Do you? Okay. Then yours is fixed. Mine isn't. This is basically the same thing we just talked about. It's just a different way to look at it. It's your horizontal shifts, tells you what's going on. You shift left, right, and what's actually happening with your coordinates or whatever. So just a different, maybe this makes you, you like looking at this better than the other side, whatever, but it's the same thing either way. Okay, we good? Oh, thank you for dropping your phone. I forgot to say, put your phones in the box for me so you can stop doing whatever you're doing too. Okay. Well, not you, I'm him. I know you just dropped yours. He's like watching a video or something. No, he wasn't. He just fell. Okay. All right. We all good so far on that? Let's put this to use. So get the other paper, and let's look at some transformations. First of all, I want to talk about what I mean by inside and outside, because you need to totally understand that so that you can wrap your mind around it. When you're trying to look at, does something affect x or does it affect y? Depending on what this is, like this is a square root, this is an absolute value, this is a quadratic, right? Inside whatever the operation is, so inside my absolute value, inside my square root, inside the square, all that stuff affects x. If it's outside of that, so like we take the absolute value, then we do something. So I do this, it gives me a new y value, then this affects that y value even more. This is outside of the square root. Even though it comes literally first in the order, this happens after we take the square root. You agree with that? So if it happens after whatever the operation is, it affects y. Before the operation, it affects x. After the operation, it affects y, no matter where it is in the equation. Okay, we good with that? All right, so it says, given each function, identify both the parent function and the transformations from the parent function. So there's a few things that we want to do here. So I look at this. This is x cubed minus 4. So that means that this is a cubic. Got to have the name. We're going to say this is f of x equals x cubed. And then I need a little sketch. Okay? Can you draw it in the air with your finger? What does a cubic look like? Yeah, it's like that, right? That's your cubic. Okay? So all you have to do here is just go like this. That's all you got to do right now. We'll talk about putting the anchor points on it, but you got the idea, you got the picture of it in your mind. Okay? Then we are going to figure out how many transformations there are and what they are. So this right here, I've got an x cubed. The only thing besides literally the x cubed is this minus 4. So I only have one. It happens after I've done the cube, which means it affects y. And if I subtract 4, what's going to happen to my graph? You can look at your chart if you need to. What happens if you subtract something afterwards? It's going to move down. So that means all that happens here is it moves down 4. That's it. Okay, easy enough? Okay, so let's look at number 2. This is a square root. So I say, all right, this is a square root function. Oh, I can spell. Square root f of x equals the square root of x. What does your square root function look like? Can you draw that in the air? Yep, it's the one that goes like this, just like this. So it just looks like this right here. These are things you've got to know. Trust me, not just for the graphing part, but what we're doing after graphing. If you know what the picture looks like, it makes your job a whole lot easier because you can do less algebra stuff that goes with it. You just understand what's happening. Okay, so now let's look at how many transformations I have. I have the 2, I have the negative, and I have this negative 1. So there's 3. So I'm going to put 3 little bullets here so I know that there's 3 things that I got to figure out. This 2 is, first of all, it's being multiplied, which means it's either a stretch or a compression. I need to figure out if it's vertical or horizontal. It's outside of the operation, so does it affect x or y? Y, which means it's vertical. And so it's a vertical. Would that be a stretch or a compression? Stretch. Stretch makes sense because you're doubling it, right? Y is the one that makes sense. X is the liar. So this right here, this 2, means I have a vertical stretch by 2. And I highly suggest you go through these left to right, right through the function, because it'll put them in, when you do that, it puts them in the order you need to actually graph them. All right, so then I have this negative. The negative in general means what's going to happen? What happens when you have the negative? It's what? It flips. It's a reflection. So I know I'm going to have a reflection, and then I just have to decide which axis. It's on the inside, so since the negative affects x, what are we reflecting in? If I change the sign on x, I'm reflecting in y. So it's a reflection in the y-axis. And then I have that -1. It's on the inside, so it's affecting x. So it's going to be a horizontal translation. Am I going to go to the right or the left? X is a liar. To the right. It looks like it should be left, right? X is a liar. I'm going to the right 1. Hey, there's no sleeping in math. Come on. What questions you got? We good so far? All right. So let's do 3. This is a quadratic. Uh-huh. Okay, good. F of x equals x squared. And then what does your quadratic look like? Yep, it's just a parabola. And you've been doing parabolas since Algebra 1 also, so that's definitely something we should know. All right, so look at that, and first just tell me how many transformations are happening. How many do you see? 3. Okay, so the squared doesn't count because it's part of this, right? But I have this negative, I have the 1/4, and I have the 6. So there are 3. Negative means it's a reflection. Do you think that, so we'll write reflection in. Do you think this is a reflection in the x-axis or the y-axis? What do you think? So does that negative affect x or does it affect y? Is it on the inside of the operation or outside? Outside. If it's on the outside of the operation, it affects what? Y. And if we change the sign on y, it's a reflection in x. You see how to think through that? So always ask yourself, inside or outside, first of all, so you can figure out if it's x or y. So this is a reflection in the x-axis. All right, so that 1/4. It's being multiplied, so it's a stretch or a compression. Is it inside or outside? Inside. So it affects what? X. And x is a liar. All right, so it looks like it should shrink by 1/4. But instead we use the reciprocal, which is 4, which makes it a horizontal what? Stretch. So this is a horizontal stretch by 4. You see that thought process? You just kind of think through the steps. Where is it? What is it doing? What does that mean? All right, so then the 6, inside or outside? Outside, so it affects y, and it means that we do what? Up 6. Everybody good with that? All right. Number 4, what's this called? Absolute value. Absolute value. And that's f of x equals the absolute value of x. And what does that one look like? Yep, it's just a v. V for value. So this is your absolute value. Okay, so look at that. Think for a second. How many transformations do you think are there? 3. So that's one reason why I want you writing this down. Anything other than this is going to count. So I've got a 3, a 5, and a negative 2, so that is 3 things happening there. So you take a second, think about what you think they are, and write those 3 down. All right, Adrian, can you tell me what that 3 does? Okay, if it's being multiplied, that means it has to be a what? Like in general. So you can look on here. So if it's going to be multiplied, it's either a stretch or a compression, okay? Is that 3 inside or outside the operation? Is it inside the absolute value or outside the absolute value? Inside. So if it's multiplied and it's inside, does it affect x or y? X. And x is a what? X is a liar. Okay? So if I multiply something by 3, it makes it sound like it should get bigger, but x is a liar, so instead of a stretch, what is this going to be? Compression. Very good. So since it affects x, this is a horizontal compression by, we use the reciprocal 1/3. Because if you're going to say compression, the number has to be smaller than 1. It's got to get smaller, okay? All right. Manuel, can you tell me what you think that 5 does? Okay, well, first of all, is it inside the absolute value or outside? Inside. So it affects x, and x is a liar. So that 5 means I do what? Exactly. I use the negative. So does that mean, how do I move, though? X is horizontal, so that's your left and right. That makes sense? So if it's x, it's always horizontal. So if x is a liar, it looks like I should go to the right. That means I'm going to go to the left 5. Okay. Jose, what does that 2 mean I do? Down 2. Very good. Okay. Any questions about that? Listen to the questions that I'm asking you, because those are the questions you should be asking yourself if you're staring at it and you have no clue. Like, that's how you get yourself through it. All right. Let's look at number 5. All right, so this is a quadratic again. So we know that's f of x equals x squared. And we should know what it looks like so. Jose, how many transformations do you think there are here? 2. I would agree with that, 2. So y'all take a second, see if you can figure out what that 1/2 and that 6 does. All right, that 1/2 is being multiplied. So in general, that means it has to be a what or a what? Compression or stretch, right? All right, so does this 1/2 affect x or y? Y, because it's on the outside of the operation. So since it's on the outside, it affects y. And if it affects y, that means it's a vertical something. Would this be a vertical compression or stretch? It's 1/2. It's a compression because x is a liar, but y is a good guy, and he don't lie. So this is a vertical compression by 1/2. That 6 is on the inside of that operation, which means it affects x. It's being added or subtracted, which means it's a translation, left, right, or up or down. If it affects x, it has to be horizontal. And since it's x minus 6, which direction do I go? To the right. Go to the right, 6. Okay. Everybody good with that? Any questions? All right, we're going to skip number 6 because you can do transformations with lines, but really we have other ways that we're much more familiar with to graph lines, so it's not worth trying to make something more difficult, okay? This stuff actually makes this graphing easier. It really kind of makes this one just a little bit more confusing, so we just don't need to worry about it with lines. All right, so number 7, what do we call this type of function? Cube root. Very good. So this is a cube root. So f of x is equal to the cube root of x. Remember that we had x cubed up there, and he looked like this, and we can't get these mixed up. This is standing up. The cube root is laying down, so it looks like this. Right? That's your cube root. Kind of looks like the root symbol to begin with, so maybe that could help you. How many transformations do you think are in this one? So we have the negative. No, we have, okay, so this 3 right here, I know that's not what you meant by 3, but this 3 right here, that doesn't count because that's part of the cube root, right? But we have a negative, that's 1. The 4, that's 1. The 1, that's 1. And the 2. So we actually have 4 on this one. Make that decision before you start so you can make sure that you don't leave anything off, and then go left to right. Don't jump around, okay? So we start with that negative. I know if there's a negative that's being multiplied, that means it has to be a reflection. Is it inside or outside the operation? Outside, so it affects y. And if we change the sign in y, we reflect in x. So then I have the 4, which is also on the outside, which affects y then. It's being multiplied, so it's either a stretch or a compression. Since that is a 4, is that a stretch or a compression? Stretch. And since it affects y, is it vertical or horizontal? Vertical. Very good. So I would have a vertical stretch by 4. Okay? Everybody good with that? I'm adding the 1, so it has to be a translation left, right, up, or down. It affects, it's inside, so does that mean I go left, right, or up or down? Like, is it horizontal or vertical is what I should be asking. Horizontal. And x lies, so which direction do I go? Left. And then what does that 2 do? Up 2. Very good. All right. We good with that? What questions you got? All right, look at number 8. Do you know what type of function that is? You ever seen that before? I highly doubt it, okay? It kind of looks like a double absolute value. That's not what it is. But this is called a signum function. It is something you will use in calculus. This is the only time we're going to look at it this year. But it's something. It can also be called the sign function, S-I-G-N. But that's confusing because there's also a sign, S-I-N-E function, and they have nothing to do with each other. So signum is kind of the go-to word. All right, so you have no clue what this graph looks like, and that's okay. It could be a graph of a monkey for all you know. It doesn't really matter. But whether or not you know what the graph looks like, could you tell me what happens to it with these transformations? You got two transformations, right? What does the 5 mean I do? Because this is inside whatever the signum does. So it affects x. That means I go to the right 5. What does this negative 1 do? Down 1. So whatever the signum is, if I gave you a signum graph that you'd never seen before, you could take it, you could move it to the right 5 and down 1, and boom, you transformed it. Okay? So I'm having you write all this stuff right here because we're going to definitely need to for the graphing and everything. But notice that even if you didn't know what that was, you can still figure out the transformations. Okay? We good? Do you feel like we need to do any more, or you think you got the hang of it? Be honest with me, because, I mean, we can do them, but I don't want to do them if you're like, no, I get this. Do we need to do them? Somebody speak up. Nobody's going to be mad at you. Yes? Okay. So let's do them. We'll do them together. So this, again, this is absolute value. So we'll just kind of skip, even though I don't want you skipping this part when you do it, we'll skip that. It's absolute value. We know what it looks like, right? So I have the negative, the 1/3, the 4, and the 7. So we have 1, 2, 3, 4. If you stare at this and you're like, I don't know what the heck is going on, here's your thought process. If you have a negative that's being multiplied, you know for sure it's a reflection. Then you ask yourself, is it inside or outside the operation? This one is inside. If it's inside, it affects x. And if I change the sign on x, I reflect in what? Y. All right. So then I have that 1/3. It's being multiplied, so it's either a stretch or a compression. It's inside, so it affects x, which means it's horizontal. X is a liar, so I don't get to use 1/3. I have to use 3, which makes it a horizontal stretch by 3. That 4 is being added or subtracted, which means I'm either going left, right, up, or down. It's inside the operation, so it affects x. X is a liar, so it looks like I go to the left, but I really go to the right. And that 7 means I do what? Up 7. Okay? We good with that? Does that make sense? Okay, good deal. So then let's look at number 10. This is a cubic. Remember, cubic looks like this. We already wrote all that out for once, so we don't have to do that again. I have a negative, a 3/2, a 3, and an 8. So I have 4 again. I know that the negative means a reflection. It is outside of the operation, so it affects y. And if I change the sign on y, I reflect in what? X. 3/2 being multiplied. So it's either a stretch or a compression. And it's on the outside, so it affects y, which makes it vertical or horizontal? Vertical. And remember that y is a good guy and he doesn't lie. So I use the 3/2. It's a fraction, but it's greater than 1. So is it a stretch or a compression? Stretch. Vertical stretch by 3/2. The 3 is on the inside, so it's horizontal. X lies, so I go to the left, 3. The negative 8's on the outside. Y is a good guy. He doesn't lie. And so we go down 8. Does that help? Like, you got to have, this is how we're going to graph things. We're not going to graph things by making a t-table, plugging in a bunch of points, and going plotting points and trying to figure out the shape. That's not what this graphing is. This graphing is understanding the big concept of how things move around. So it's important that you can decipher this. Any questions at all? All right, so flip it over. We're going to jump down to number 13. Okay. What? Go ahead. Yeah, flip it over. 13. So our parent function, what is this one called? Cubic. So it gave us a picture. We have to know from the picture that it is a cubic, and that means f of x equals x cubed. All right? That's all we really need the graph for. So we're doing the opposite of what we just did. We had a function, and we figured out what the transformations are. Here, they're giving us the transformation, and we have to write the equation. So if we take that f of x, and then we vertically stretch it by a factor of 4 and translate it 1 unit up, we'll have a new one. So since it's a new one, I'm going to call it g of x. Okay? Because I don't want to call it f of x again. If it is vertically stretched, then that means I'm going to have to multiply something. Will the thing I'm multiplying be inside or outside of the cubic? Outside, because it's vertically, that means it affects y, so it's not before I cube it, it's after I cube it. And y doesn't lie, so if I vertically stretch by a factor of 4, it'll be 4 times x cubed, like that. So when I say after, that doesn't mean left to right after. That means after I cube it, then I would multiply by 4. I translate 1 unit up. Maybe I shouldn't. So should that 1 be on the inside? That 1, and what do I do to get that 1 on there? How does it look? Plus 1. And that's it. Okay, does that make sense? All right. So then C, we're going to call this one h of x. And we're not changing this one. We're changing the original one again. You're going to vertically compress it by a factor of 1/3 and translate it 5 units left. Write down what you think that would look like, and if you're wrong, it's fine. Just kind of dump it out of your brain onto the paper, then I'll walk you through it, and we'll talk about it. Okay, if I'm going to vertically compress, being multiplied, it's vertical, it's outside the cube, right? And then, and if y doesn't lie, so it will be 1/3. Then I'm going to translate it 5 units left. That affects x, so it has to be on the inside, like before we cube it. So this is going to have to be x. And if I'm going to the left, would it be plus or minus 5? Plus, because x lies, right? It's going to look like the opposite, and that's what you should have, okay? Make sense? You get that thought process there? All right, let's try 14. This is a what? What would you call this? Cube root. Very good. Cube root. So f of x equals the cube root of x. So we're going to reflect in the y-axis, translate 4 units right. So see if you can write down what you think that would be. Try it. You can always change it if you didn't have it right. You don't know what you don't know until you actually try. Oh, and we'll call it g of x. If I reflect in the y-axis, is that negative going to be inside or outside the operation? Inside, because if I reflect in y, it affects x, right? So it has to be on the inside. 4 units right, will that be on the inside or outside? Inside. So everything I'm doing is all on the inside. So I'm just going to have this big old cube root. So it means I'm going to have a negative in here so that I reflect in the y-axis. This 4 units right is going to be x minus 4, but you have to make sure that you have parentheses here, okay? If you're going to do anything, if you're going to multiply anything by x or have that negative in there and you have a translation, you have to have parentheses there because everything always has to be factored all the way out. Okay, so this negative changes the sign on x, that reflects it in y, and then this 4 would move it to the right 4 units. Okay, we good with that? All right, last one we're going to do. I want you to do C. We'll call this h of x. And again, you're going back to the original cube root. See if you can get that one written down. Okay, so I have two things going on here. I have a horizontal compression and a translate 5 units down. Horizontal compression is going to be inside because it affects x. Translate down is going to be outside the cube root. Now, that horizontal compression, x lies. So if it's a horizontal compression by 1/2, 1/2's not what goes in there, it's 2, right? So I have h of x equals, I'm going to have the cube root, not 1/2, but 2 times x, and that's the only thing that needs to be under the cube root. And then I translate 5 units down outside the cube root is going to be minus 5. Okay. Any questions about that, if that's not what you got? Got any questions at all? No question? All right, so then that's it for today. We're not going to do the rest of those. Your assignment is in Delta Math.